Hello students, welcome back. This is Shivleela from Upper Public School. How was the class last clipping? It was nice, right? We did some magic and all, and we started to solve exercises also. Number of multiples it will be not given. One hint will be given. We have to find the general rule for that. We have done it, right? Yes. Last one problem is remaining from that exercise, first exercise, remaining all second exercise. That one, as you all know, I'll always solve one and another one. If it is so similar, then I will leave it to for you, right? Come on. Now, see, 11th one. I did not write the problem. I just drawn the figure. Okay. These are not the boxes. So these are the matchsticks. Okay. These are the matchsticks. Okay. So problem is given. Okay. Problem is given. What is the problem? Given problem. Let me make all the matchsticks first. Fine. See, look at the following matchstick pattern of squares. Okay, the squares are not separate. Not separate. They are together. Okay. Two neighboring squares have a common matchsticks. Two neighboring squares have a common matchsticks. Okay. Observe the patterns and find the rule that gives the number of matchstick in terms of the number of squares. Okay. See what they said. Squares are given. For one square, 4 matchsticks. For 2 squares, 7. For 3 squares, it is 10. Here, 13. For 4 squares. For n number of squares, that means I have to represent the general representation to say number of matchsticks depend on number of squares. Okay. Now, what to do? How to do? First, A, number of matchsticks. How many are there? Number of matchsticks. A, 4 are there. B, 7. C, 10. D, 13. Right? Right? Now, see how general representation, general rule. Let me say general rule. Right? Now, what is the general rule for this? See, 4 twos are 8, but here 7. 4 threes are 12, but here 10. Here also less. So it is not, we can't say directly, first exercise. 1 letter 2 means the rule was 2n. But here we can't say 4n directly. Right? Because 2 means we don't have 8 matchsticks, here only 7 matchsticks because both the squares are not separate. They are together. Right? So what to do? See here. For two squares, one matchstick is common. For these two, this is common. For these two, this is common. For these two, this matchstick is common. For these two, this matchstick is common. For these two, this matchstick is common. Right? So keep that one matchstick common. Okay, keep that one matchstick common. If we keep those matchsticks common, what will be remaining? This will be 3, this will be 6, this will be 9, this will be 12. Right? So now I can rewrite this. See, this is 3. These all are multiples of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, right? So let me write these like that only. 3 into 1 plus 1, 3 into 2 plus 1, 3 into 3 plus 1, 3 into 4 plus 1. See number of matchsticks. 1 triangle, 4. 2 triangle, 6. 3 triangles, 10. 4 triangles, 13. All are correct. So here I have some pattern. In this, see it. 3 and 1 is common in all. It is constant. 3 and 1 are constant. The only one thing is varied means this. This is varied. It's a variable. I can consider it as a variable. That means in this space, I should use a variable. And this represents number of squares. 1 square. 4 matchsticks. 2 squares. 7 matchsticks. 3 2 is 6 plus 1, 7. Right? 3 squares. So 3 3 is a 9. 9 plus 1, 10. 10 matchsticks. Right? So, therefore, general rule, see, 3 plus 1 will be common. Instead of these changing number, we can use the alphabet to represent that. Let us use as n. Okay, so here n is number of squares. 1 square, substitute 1. 3 ones are 3 plus 1, 4 matchsticks. 2 squares, 3 twos are 6 plus 1, 7 matchsticks. 3 squares. Got it. So for n number of matchsticks, this is the rule. Did you get it? Understood? In the same way, next one also. B1 also same way. Instead of square, it is triangle. Okay. Let's see. Figure 11.7 gives a matchstick pattern of a triangle as in exercise 11.11a above. Find the general rule that gives the number of matchsticks in terms of number of triangles. Just like this only. Instead of square. Here square is there. Here triangle. Rest all is same. Here also one matchstick is common for 2 triangles. Okay. So try it. Get the answer. Fine. Now let's move to the next exercise. Very easy next exercise and very small also. See the side of an equilateral triangle here. Already I have written and kept also. The side of an equilateral triangle is shown by letter L. Is shown by letter L. Express the perimeter of equilateral triangle using L. What is the formula to find the perimeter of equilateral triangle? Perimeter of equilateral triangle. Equilateral triangle is equals to 3 times the side, right? But side is given as L, right? So therefore, perimeter equals to 3 times L. This is nothing but you can even write it as 3L, right? So easy. What we did, nothing. Side is given as L, substituted over. Right? In the same way, this one also. Actually, I would have leave it for you only, but still I have written. See, the side of a regular hexagon is denoted by L. Express the perimeter of the hexagon using L. Again, the perimeter of regular hexagon is nothing but 6 sides. Sum of all sides, no. Sum of all sides. Here all sides are equal. So 6 into side. But the side is given as L. Side is given as L. So therefore, perimeter equals to 6 times L or else 6L. Right? Yes. Next, third one. A cube is a 3-dimensional figure, right? Cube is a 3-dimensional object or a shape, I can say. Here, edges, even here also, edges is given. Then what is the total length of edges? So that we have to find out. Same way, just like this only. Or if all are given as L, then total how many edges will be there in a cube? Count. In a cube, there will be 6 squares. Each square has 4 sides, but all 6 squares are not separate. They are joined together means their sides are also common for two faces. Right? So total how many edges will be there? How many vertices will be there? Third one. Cube. How many sides are there? They are given all are real. Okay. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Then perimeter. A cube is a three-dimensional figure as shown in the figure 11.11. It has 6 faces and all of them are identical squares. The length of an edge of a cube is given by L. Find the formula for the total length of the edges of a cube. So, length of one edge. Let me write here only. Length of an edge. An edge or one edge, both are same, that is L. Number of edges, how many are there? Number of edges. How many are there? 12. Then total length of edges. Total length of edges is nothing but we have to add all 12 length. That means all length are same. Then it is nothing but 12 times L. It is nothing but 12 L over. Fine. Yes. Now, fourth one, let me read it. The diameter of a circle is a line which joins 2 points on the circle and also passes through the center of the circle. Here figure is given. AB is the diameter of the circle, C is the center. Express the diameter of the circle in terms of its radius. See, they have given the figure like this. Okay. C AB. This is radius. Already you know this one. No need to define it, right? You know. Radius means the distance from the center to the circumference. Diameter means the longest chord which passes through the center, right? So now, from here to here, radius means from here to here also it is a radius. From here to here also it is a radius. Then one diameter is nothing but 2 radii, right? 1 radii plus 1 radii. 2 radii, isn't it? So that is what you have to write. Okay? Diameter D. Radii or radius is R. Then diameter, one diameter equals to 2 radii. Right? This is geometry. This is geometry. This is geometry. Even previous two also was from geometry only. But still we are using algebra. Right? So algebra covers geometry as well as arithmetic also. Right? Now, fifth one. Fifth one is very, very, very easy. See, problem is half a page. Problem is itself half a page. But solution is one line. Solution is one line. See, I'll read for you. Okay. To find the sum of 3 numbers for 14, 27 and 13, we can have 2 ways. We may first find, we may first add 14 and 27 to get 41 and then add 13 to it to get the total sum 54. Or we may add 27 and 13 to get 40 and then add 14 to get the sum 54. Thus, 14 plus 27 plus 13 equals to, see they what they said, 14, 27, 13. 14 plus 27 plus 13 equals to 14 plus 27 plus 13. Okay. This can be done for any three numbers. This property is known as associativity of addition of numbers. This is already explained, associative property in whole numbers, right? Yes. Express this property, which we have already studied in the chapter on whole numbers, in a general way by using variables A, B, and C. That's it. See here. 14 plus 27 plus 13 is also 54. 14 plus 27 plus 13 is also 54. Answer is same. Now, instead of 14, 27, 13, we have to use A, B, C. That's it. This is the answer. Oh, only this much. Still, let us write a proper solution. Okay. Let's have general representation of associativity of addition of numbers is A. Okay, let me write it down, or else you may not see this. It will go out of the screen. A plus B plus C equals to A plus B plus C. Okay. Over. So second exercise completed. What's the time? 17 minutes. Is it okay? No. Minimum, let us engage the classes for 30 minutes. Right? Yes. So now we'll go to 11.3 exercises. But first problem itself, I'm not going to do by myself. Okay? I'm not going to show you also. I'll just read it and I'll explain it. You do it by yourself. It's very easy. They have given three numbers. Okay? Use those numbers to make an expression. Okay, again, don't get confused that means you have said the combination of a variable and a number, constant number, gives an expression. Expression means along with an operation. Okay, it might be combination of only numbers or the combination of constant number and a variable. No issue. Okay, make up as many expressions. Exercise 11.3. Exercise 11.3. First one. Make as many expression with numbers, no variable, okay? As you can from three numbers. Numbers are given 5, 7, 8. Okay? Every number should be used not more than once. Use only addition, subtraction, and multiplication, not division. They did not give division here. So use only these three. They have given the hint also. Okay? Then you can say this one. Okay, next second one. Okay, second one. Let me write it on the board. Okay, not the problem, but these are right. Second one. They said which out of the following are expression with numbers only. See, few expressions are given. Y plus 3, B. 7 into 20 minus 8 times Z, C. 5 into 21 minus 7 plus 7 into 2 D 5 E 3x F 5 minus 5n G 7 into 20 minus 5 into 10 minus 45 plus P. What they said, which out of these are only expressions with numbers only? Numbers means no variables. A, C, variable is there. B, variable is there. C, no variable. D, no variable. Again, E, variable is there. F, variable is there. G, variable is there. So therefore, C and D are the expressions with numbers only. With numbers only. Okay? Yes. Next one. Identify the operation informing the following expression and tell how the expressions have been formed. Expressions are given in third problem. Okay? Expressions are given. What we have to do is which operation have been used and how does it formed. Okay? Come on. So for this, the better make a column. Okay? Third one, A given like Z plus 1, Z minus 1, Y plus 17, Y minus 17. Solutions we have to. So better make columns. Okay. Expression. Okay. Operations. Okay. Then they asked statement. How they formed. Right? Okay. This is expression. This is operation. This is statement. In statement, how does it formed? Okay. Now, see here. Z plus 1. What is the operation here? Addition, right? Operation is addition. Statement 1 is added to Z. Right? Then Z minus 1. Operation is subtraction. Right? Subtraction. 1 is subtracted from Z. See, 1 is subtracted from Z, you know. Right? If you don't get this one, imagine a number here. Instead of Z, Z is also a number. But which number, don't know. You can give a value for that. If you give 5, 5 plus 1, you get 6, you know. Operation is addition. So, how? You added 1 to 5. Right? So, like that. And subtraction, 5 minus 1, 4, subtraction. How you did? You subtracted 1 from 5. Right? You subtracted 1 from 5. So, therefore, it is 1 subtracted from Z. Same with this one also. Y plus 17, Y minus 17. Same. Here addition. Operation is addition. Here operation is Subtraction. Your operation is subtraction. What addition? What number is added here? What number is added? 17 is added. 17 is added to y. Here 17 is subtracted. Okay, 17 is subtracted from y. Okay, this is the way. Like this only B1. See, all you can do by yourself. Okay, I'll do B also. Okay, B and C I'll do. Again, D is your work. Okay, come on. B1. 17 y by 17 5z. 5z. Right? Let me draw the columns. You can even directly write also. Okay, 17y operation is multiplied. How? 17 times y. Directly also. But here if you do like this, it will be very easy to recognize also. This is organization. It's very easy, right? See directly here which operation, how it is done. If you, without a column, if you make a arrow mark and if you write, it may confuse you. That's why I said, okay? And it will be very neat also, right? Expression, operation, statement. Okay. Expression, operation, statement. Okay. First one. 17 times y. What is the operation here? No symbol is given. Here at least plus was given. You know that plus is addition. You have already learned it like that. But integer said not plus is not addition, but when you have two same sign, you have to add. Right? That's right. Here both have same sign in that way. But here no symbol is also given. Then how can we identify? Already as I said, if there is no symbol is given, then if a constant and a variable written together, then we can judge it as multiplication. They both have been multiplied. Okay, so operation is multiplication. Multiplication. Okay, so small I wrote. You know the spelling, right? You can write by yourself. And how does it form? 17 is multiplied to y. Or y is multiplied to 17. Anyhow you can. 17 is multiplied or y is multiplied by 17. Let me write it as y. Okay. Y is multiplied by 17. Next one, to y divide by 17. Operation division. Right? So how? Y is divided by 17. Right? Next, 5z. Again, what is the operation? Multiplication, right? Operation is multiplication. Multiplication. How? Z is multiplied by 5. Right? Right? Yes. Now, see one thing. See, we have 2 times y plus 17 and 2 times y minus 17. Right? Now, do it as usual. Okay? Expression, operation, and statement. Statement. Right? See, here, what is the operation? What is the operation? Is it only addition? Is it only addition? No. Multiplication is also there. So two operations happen. Addition and multiplication. Addition and multiplication. Right? Then statement. How can we write? See, 17 is added. 17 is added to what? To 2 times y. Right? 17 is added to 2 times y. Right? Same way next one. 2y minus 17. Multiplication and subtraction. Multiplication and subtraction. Subtraction. Right? So, what? Here 17 was added, but here 17 is subtracted. From what? From 2 times y. Got it? 17 is subtracted from 2 times y. Right? Yes. Got it? Somehow. How is it? If you got to know what is an expression, how does it formed, then it's very easy. There, if you failed, this will be difficult. So, even now, if you don't understand, go for the part 1 video of this chapter. Okay, watch it, then see. It's very easy. If there is a number instead of a variable, then this already you have done and left. Already you have done it. This is only two digit and single digit. You have done it with the 3, 4, 5 digits. It's very easy for you. So don't get confused or don't be panic with this variable. This is also a number, but not fixed. That's it. Okay? Fine. So this is enough for today. Still, don't think it is at the end. This is a half part of third exercise. Still, there are many. Still, 3 bits are there from this exercise. Then we have still 2 more exercises from this chapter, right? So still you have to frame the. Now see, expressions are given. Now we said operation and statement. Next they have given statement. We have to frame the expression. Then without numerics or alphabetical representation also it's given. We have to. Okay. Very easy if you understand the concept. Fine. Okay. Enjoy these problems. Bye bye.